Good morning, students. Today we will start chapter 1, real numbers. Real numbers, which is denoted by letter R. It is combination of rational numbers and irrational numbers. Rational numbers are the numbers which can be represented in form of p by q, where q should not equals to 0. You can take examples 2 by 3, 1 by 7, 4 by 9, minus 3 by 7, and so on. Irrational numbers means which cannot be represented in form of p by q, like root 3, root 5, root 7, pi, and so on are the examples of irrational number. Now about their decimal expansions. The decimal expansion of any rational number is first terminating, means we get remainder 0. The second we get repeating decimal, means recurring. Third we get non-terminating but repeating, means recurring. Whereas in case of irrational number, the decimal expansion of these numbers are non-terminating and non-repeating also. Okay, see here we are getting non-terminating but repeating, and in case of irrational numbers, non-terminating and non-repeating. So the set of rational numbers and irrational numbers called real numbers. Okay, now your first exercise 1.1. in this you have to learn about Euclid's division lemma. What is Euclid's division lemma? Okay, this is nothing new for you, but the terms I am explaining. Euclid is a mathematician. He is known as father of geometry. Division means this lemma is related, this theorem is related with division process, and lemma is set of steps. Okay, so Euclid's division lemma. What is Euclid's division lemma? I am explaining here. If a and b are two positive integers, a and b are two positive integers, then they must satisfy this condition: a is equals to bq plus r, where your r should equal to 0, or it should be greater than 0, or it should be smaller than b. Means r cannot be ever negative. It should be equal to 0 or it should be greater than 0, but it cannot be greater than b. R should be always smaller than b. Like if you divide any number a with b, you will get some quotient q, like here we are getting. So if you are getting some quotient and some number here, if you subtract this, you will get remainder. This process you are already doing. Okay, this b is called divisor, a is called dividend, this is quotient, and after subtracting these two we are getting r, that is remainder. Okay, let us take some example. Suppose We want to divide 45 by 6. Okay, so how we will divide it? 6 sevens are 42 and 3 we are getting as remainder. After subtracting this, we are getting 3 as remainder. So we will write it like this: 45 is equals to 6 into 7 plus 3, means A is equals to BQ plus R. Our A is 45 here. A is 45, B is 6, quotient is 7 and remainder is 3. You can see A is equals to BQ plus R means A is equals to B, B is 6, Q is 7 and remainder is 3. This whole thing is called Euclid's division lemma. We take help of this lemma to find HCF of any 2 numbers or 3 numbers. Okay. Now I am explaining you how to find HCF of any 2 numbers using Euclid's division lemma. Suppose we have 2 numbers 125 and 45 for example, and the smaller number is always divisor. So 45 we take as divisor, 125 will be quotient. So 45 2s are 90. Now subtract 90 from 125, we will get 12 minus 9, 3. So now remainder we are getting 35, quotient 2, this is divisor and this one is dividend. Now again this number will become dividend, your divisor. If you are getting some remainder, then your divisor will become dividend and the remainder will become divisor. Okay, so 35 ones are 35, so 10 we will get. When we subtract this, we will get 10. Again we have not got remainder 0, so again we will divide. This remainder will become divisor and the previous divisor will become dividend. So it will, when we divide this, 10 3s are 30 and when we subtract this, we will get remainder 5. Again, because remainder is not 0, so we'll continue the process. 5, our remainder will become divisor and the previous divisor will become dividend. So 5 2s are 10. Here our process end here because we are getting remainder 0. Now how to find, using this long division process, how can we find HCF of these 2 numbers? Suppose for first step we will write 125 is equals to 45 into 2 plus 35. Okay, dividend is equals to divisor into quotient plus remainder. Dividend is equals to divisor into quotient plus remainder. This is our first step. Now what is our next step? What is our next dividend? Next dividend is 45. So we will write it 35 into 1 plus remainder 10. Dividend is equals to divisor into quotient plus remainder. Okay, then this is our second step. Now what is our third step? The next dividend is 35 and this can be written as 10 divisor into quotient plus remainder. Remainder is 5. The fourth step is 10 can be written as 5 into 2 plus remainder 0. So For this we have got 4 steps. First step, second step, third step, fourth step. In the last step where you are getting remainder 0, that divisor will your HCF. So HCF of 125 and 45 is equals to 5. HCF is highest common divisor is 5 we are getting. In this way we find HCF of any two numbers using Euclid's division lemma. We have to continue this process till we get remainder is equals to 0. This process is called long division method, and with the help of this process we find HCF of any two numbers or three numbers. So your first question is find HCF of 135 and 225. Always the divisor is always the smaller number. Okay, you can write A is equals to BQ plus R. So what is your A here? A is 225 and your divisor is 135. Definitely we can divide it by ones. 135 ones are 135. Subtract it. 5 minus 5 0. 12 minus 3 9 and 1 minus 1 0. Remainder we are not getting 0. So we'll continue the process. 90, 135, 135. So 90 ones are 90. Here we will get 5. 13 minus 4 9. Remainder is not 0. So again we will continue the process. 45 2s are 90. So how we will write this in form of A is equals to BQ plus R? 225 is equals to 135 into 1 plus remainder 90. Okay. Then second step will be 135 is equals to 90 into 1 plus 45. And the third step is equals to 90 is equals to 45 into 2 plus remainder is equals to 0. See here in third step we are getting remainder 0. So it means that the divisor, what is the divisor of third step? Divisor of third step is 45. So HCF of 135 and 225 is 45. Okay. So your process ends here.